Okay, welcome back to another episode of Mr. A's Geometry Podcast. Today we're going to be talking about parallel line proofs, proofs involving parallel lines. On the board we have a fairly typical example. This is about as simple as they get. We have a shape that, well, you should recognize as a parallelogram. We're told a couple of things. We're given that AB is parallel to DC, top line and the bottom line. We're also told that those same lines are congruent, AB congruent to CD. So we can start by marking up our picture. We know that this line is parallel to this one. And we also know that AB is congruent to DC. So we have a pair of lines that are both parallel and congruent. Whenever you have a given about parallel lines, you should be thinking, what angles can I find? You're looking for alternate interior angles, alternate exterior, corresponding, or same side interior. The ones that you're most commonly going to use are alternate interior and corresponding angles. So look for them first. When you have a parallelogram, one thing you might notice is that all of these angles are interior angles, right? The lines are here. So the whole picture is in between the parallel lines. That's what an interior angle is. So look for interior ones first. When you have these two lines parallel, AB and CD, hopefully you can see a pair of alternate interior angles. If you see it, it's going to be here and here. Right? So we know that this line angle ABD is going to be congruent to this angle BDC. How do we know? Well, these angles are alternate interior angles to these two parallel lines. That's what you're looking for, a pair of alternate interior or corresponding to some angles that you can use a fact from parallel lines. So how do we set this proof up? We have these angles congruent. We were already told that these sides are congruent. They want us to say that these lines are parallel, AD and BC. So those are these other two sides of the picture, right? In order to do that, we're going to have to show that they either have congruent alternate interior angles, congruent corresponding angles, alternate exterior, or maybe same side supplementary. Again, you're probably looking for either congruent alternate interior or congruent corresponding angles. Most of the time it's going to be one of those two. So if you haven't seen it already, the trick here is going to be to get these triangles congruent. Right? Hopefully that's a fairly easy step for you. We already have a side. We figured out how to get this angle. And if you see how to get these congruent, the easiest way would be to go over here, flexive on DB, and you've got side, angle, side. So let's go ahead and get that much down in our proof, see where we can go from there. We have our givens, of course. Step 2, your taste. I'll go for reflexive first, nice and easy. I'm going to say DB, congruent to DB, reflexive. And then I want to talk about these angles that I found. Up here, angle ABD, and down here, angle CDB. So I'm going to say angle ABD is congruent to angle BDC. And the reason I know is that they're alternate interior angles. So this reason is a little bit long, but just think about what you're trying to say. You have parallel lines, so you know the alternate interior angles are congruent. That's what you're going to write. You're going to write parallel lines cut by a transversal have congruent alternate interior angles. Right? We have a pair of parallel lines cut by this transversal DB. So this gives us alternate interior angles congruent. Well, now we have side, angle, side. So we can go ahead and say these two triangles are congruent. So in step 4, triangle ABD, congruent to triangle BDC, and our reason is side, angle, side. So at this point, we've taken our parallel lines in our given, used it to find a pair of alternate interior angles. Now we have side, angle, side congruence on these triangles. What can we do with that? Well, whenever you get triangles congruent, what usually comes after that? CP, right? So what can you use to help you get these two lines parallel? what piece of those triangles is going to be useful? Well, on your paper you can turn it. If you're looking at a board, maybe go like this. If you have an iPod, flip it over. But trying to get these two lines parallel, again, we're only dealing with interior angles because everything's inside here. So hopefully you can see a pair of interior angles. Can you? If not, take a look here at ADB and here at CBD. These two angles, I'll use red for these. These are alternate interior angles for the other set of parallel lines, right? If you look this way, here are our parallel lines, AD and CB. Here's the transversal, right? So this angle here and this angle here are alternate interior angles. And by the way, they're corresponding parts of these triangles, right? This angle is opposite this double tick side. This angle is opposite this double tick side. So I can say that those angles are congruent CPCTC. And that'll give me alternate interior angles that are congruent. So in the proof, step 5, I'm going to say angle ABD is congruent to angle CBD. My reason, CPCTC, on this pair of congruent triangles. And now I can say that these lines are parallel. In step 6, I have AD parallel to BC, right? These two lines, because, again, long reason, but just think about what you're trying to say. I have two lines cut by a transversal, and I have figured out that the alternate interior angles are congruent. So those lines have to be parallel. Two lines cut by a transversal with congruent alternate interior angles are parallel. That's what you're going to write. Two lines cut by a transversal with congruent alternate interior angles are parallel. If you have two lines cut by a transversal and you know that the alternate interior angles are congruent, then those lines have to be parallel. And that's your proof. Put a proof box and you're all done. The trick to these is being able to spot the alternate interior angles, the corresponding angles, and so forth. In this problem, notice all that we've used are alternate interior angles. And more often than not, those are going to be the ones you're looking for. In the next problem we take a look at, we'll use both alternate interior and corresponding angles, so you can see how the two interact. Thanks for watching. As always, if you have any proofs that you'd like to see me do in particular, email them to me or let me know in class, and I hope you have a great day.